Hello, welcome back to Flipped. We are on the final portion of this chapter, which is called redox reaction. A redox is made of two words, reduction and oxidation. Okay, you can see the color coded. Red is from reduction, ox is from oxidation. When we put them together, it's called redox. So what exactly is a redox? It's a chemical reaction whereby oxidation and reduction take place together in the same reaction. So for example, back to my favorite formula, okay, A plus B giving me C plus D. Oxidation has to happen with reduction at the same time. For example, A undergoes oxidation, B undergoes reduction. Only then can it be considered an redox reaction. If only, for example, oxidation occurs, okay, it's not called a redox because only oxidation occurs. Only it has to be complemented with a reduction to be called a redox. Okay, so what is exactly a reduction and oxidation? Okay, it basically has four meanings. It can be in terms of state, in terms of hydrogen, in terms of oxygen, in terms of electron. So basically, oxidation and reduction has four meanings in terms of SHOE. Okay, state, hydrogen, oxygen, or electron. In terms of state, oxidation is defined as an increase in oxidation state. Okay, in terms of hydrogen, oxidation is defined as losing hydrogen. In terms of oxygen, oxidation is defined as gaining oxygen. In terms of electron, oxidation is defined as losing electrons. Okay, the opposite applies for reduction. In terms of state, reduction is defined as decrease in oxidation state. In terms of hydrogen, reduction is gaining H. In terms of oxygen, reduction is losing O, oxygen. And in terms of electrons, reduction is gaining electrons. So you can see that they are opposite of each other. Oxidation and reduction are basically opposites of each other. And how do you remember them? There is this mnemonic called SHOE, SHOE. Okay, you can remember that there are four definitions to oxidation and reduction. Let's move on to something called oxidation state. Oxidation state is called a charge of an atom or ion. So there are two kinds of oxidation state. First one is in elements. Next one is in ions. In terms of elements, they are always zero. What do I mean? If I have an element from periodic table, for example, say aluminium, just aluminium metal, it's zero. Okay, there's no charge to it. What about say chlorine gas? Okay, this is also an element. This has no charge also. What about, let's use bromine. Okay, it's also zero, Br2, because they have no charge. That's why elements have zero charge. But things get more interesting in ions. Okay, in group 1 metal, they have +1 charge. Group 2 metals have +2 charge. Group 3 metals have +3 charge. Let me give an example. Group 1 metals are, for example, potassium plus. Group 2 metals, for example, calcium 2 plus. Group 3 metals, aluminium 3 plus. So one thing you have to take note is this is +1 in oxidation state, but if you write it out in with the ions itself, it has to be numbers first before the plus sign. Whereas in this case, it's the plus sign before the number. Okay, and another thing to take note is +1 charge. You don't write the 1 here. Okay, if you write a plus, it's just understood as 1 plus. Okay, so these are the few examples for metals. What about others? For example, halogens, group 7. We have covered this in our periodicity chapter. Okay, an example of halogen, okay, is actually here, but this one is by itself, Cl minus, okay, -1 charge. Halogen can also have +1, +3, +5, or +7 charge, but that's very rare. Okay, so I would suggest that in your syllabus you can just keep this at the back of your mind. Okay, it rarely comes out. Hydrogen, usually it's +1, H plus. Oxygen is +2. Sorry, 2 minus. Okay, this is my bad. Shouldn't be a +2, so it should be a -2. Okay, rarely can hydrogen be -1, and rarely can oxygen be -1 as well. Okay, so these are oxidation states of elements and ions. Let me move on to something that's a bit more tricky. It's called oxidizing agent and reducing agent. So what do you think of the word agent? Agent is a word, okay, that, for example, let me give an example in terms of CIA or FBI, you have heard the word sabotage agent, right? So what does a sabotage agent do? They sabotage, like machineries, enemy plans, etc. So a sabotage agent's job is to sabotage. What about oxidizing agent? reducing agent. So their job is to oxidize, and his job is to reduce. Kind of makes sense, right? Because they are the agent for it. So what's the definition for oxidizing agent? First, it's a substance that oxidizes other substances, okay, by undergoing reduction itself. So if you recall in the previous slide, reduction, okay, it's gaining electrons. Oxidation is losing electrons. So back to my equation, A plus B giving us C plus D, for example. Okay, if I want to focus on A, okay, let's say that A is the oxidizing agent. It means it oxidizes other substances, for example B, by making B lose its electrons. Okay, so B now loses electrons, and now A undergoes reduction itself by using up the electron for itself. So what do I mean? If A is the oxidizing agent, it absorbs the electrons from B. Kind of makes sense, right? Because it oxidizes other substances, make B loses its electron, and itself taking in the electron, which is called reduction. Okay, so A is the oxidizing agent. Some examples of oxidizing agent are acidified potassium manganate 7, acidified potassium dichromate 6. So manganate one turns from purple to colorless, and dichromate turns from orange to green. So if you observe these color changes, you can be sure that oxidizing agent is present in a solution. So what about another one? Is group 7 halogens. Okay, they want to gain electrons to obtain noble configuration. So what do I mean by this? For example, I have chlorine. Okay, chlorine, as we know, they have 7 electrons surrounding it. 1, 2, 3, 4, 5, 6, 7. They desperately need just one more electron, you see, to fill up its outer shell so that it obtains a noble configuration, like a noble gas. So where do we get this electron from? Usually it gets from its reacting, whatever it's reacting with. So you can imagine that A is now chlorine. It wants to absorb this one last electron from B, and hence making chlorine an oxidizing agent because it oxidizes B. Okay, it does its job by oxidizing other people. So on the other hand, we have reducing agent. It's a substance that reduces other substances, okay, making them gain electron and undergoing reduction itself. So reducing agent undergoes oxidation, okay, itself. And this is in terms of losing electrons from itself. So back to this equation, it's the same thing. A plus B giving us C plus D. We want to focus on B, okay? So assuming B is our reducing agent, what do I mean? It reduces other substances, okay? It forces this A, for example, to take up the electron. So it passes its electrons to A, okay? And now it itself undergoes oxidation, where at the same time forces A to take up its electrons. And now A will undergo reduction, okay? And hence, B has done its job as a reducing agent by reducing A. So some examples are potassium iodide, which turns from colorless to brown. So if you observe this in the solution with potassium iodide, you can be sure that potassium iodide is the reducing agent. Let me give an example in terms of group 1 metal. Group 1 metal, we have, for example, potassium. Okay, it's a classic example. We have this one electron. Okay, it's a sore eye. Okay, in terms of potassium. Okay, it wants to get rid of this electron so desperately that it will force this electron upon its neighbor. Okay, just give it away to A. So in this example, B is potassium. Okay, you want to give away this electron so that it can obtain noble configuration. Okay, so with all this in mind, let me do a question for you. Okay, so basically this question, we know that it's a redox reaction, okay, because it's in this chapter, but we want to identify the oxidizing and reducing agent in this reaction. Okay, first of all, my first step is always to write down the charges for each substance. Cl2, I know its element is always 0, same as I2. Okay, there's no doubt about it. It's always 0. Okay, so if you see an element in there, just put it as 0. But if you see an ionic compound like potassium iodide, potassium chloride, there has to be charges. Okay, so we can see that potassium is group 1, so it always has the charge of +1. Alright, so same here, +1. I, okay, is group 7. It has a charge of -1. And hence when we combine them, they have become a neutral molecule. Chlorine, on the other hand, also has -1 charge. So, if you write it down in terms of equation, okay, it's like this. Cl2 plus 2Ki giving us I2 plus 2KCl. But we have to break them up into their individual ionic charges. So for Cl, okay, in terms of Cl, we can see that this is the first part is reactants, right? The second part are products. In terms of Cl, it goes from 0, oxidation state goes from 0 to, what do you see here? -1. Am I right? Whereas for iodine, it goes from -1 here. Okay, when it's in product form, it's 0. So you can see that 0 to -1, it's, what do you think? It's actually reduction, right? Undergoes reduction, right? Because from a higher number to a lower number is called reduction, okay? Because it decreases in oxidation state. On the other hand, iodine undergoes oxidation. Makes sense, right? Because it undergoes from a very negative number to a higher number. It's not positive, but increases +1. This one -1. So if it itself undergoes reduction for Cl, that means it serves as an oxidizing agent. Makes sense, right? Because it oxidizes others and hence itself getting reduced. It's like it sacrifices itself for the greater good. Okay, it oxidizes others, itself getting reduced. On the other hand, iodine itself undergoes oxidation, and so we are sure to say that it's a reducing agent. Okay, so you see my point now. If it undergoes something, it's the opposite agent. Okay, so for example, if it undergoes reduction, it's an oxidizing agent. If it undergoes oxidation, it's a reducing agent. Okay, hopefully this question clears up any doubt you have for oxidizing and reducing agent. And with this, we are done for this chapter, which is chemical equation.